The record books do not update themselves in real time. They are written afterward, carefully, by people who compile measurements, verify totals, and assign the kind of language, record, historic, unprecedented, that carries real scientific weight. But sometimes the record books are visibly being written while you are watching. Right now, today, the record books are being updated in Michigan's Upper Peninsula and Wisconsin, in the NWS archives for Green Bay and Wausau and Marquette. They are being updated in the East Coast severe weather history for the Mid-Atlantic, where a Level 4 moderate risk designation that arrives only a handful of times per decade in that region has just been issued for Washington, D.C. So Richmond and Raleigh. They are being updated in the aviation records at Seattle-Tacoma International Airport, which set a snowfall record when this storm first came on shore. They are being updated in the power grid disruption ledgers for 500,000 American households that lost electricity. And they are being updated in the tornado warning records for the East Coast, where 36. 6 million people are currently under tornado watches. When this many records are being written simultaneously in this many categories, across this wide a geographic footprint, in the middle of a single coherent weather event, the word for what you're watching is not severe. It is not dangerous. It is historic. It is actively unfolding. The most consequential phase, the East Coast severe weather outbreak on Monday, has not yet delivered its full verdict, which means you still have time. But not much. Here is the insight that most coverage of this storm is missing, and it is the insight that explains why this event is not just a collection of separate weather disasters happening to overlap on the same week. The March 13th through 17th, 2026. North American storm complex is a textbook extratropical cyclone behaving at the absolute outer edge of what that category of storm can produce. An extratropical cyclone is not a hurricane. It does not draw energy from warm ocean water. It draws energy from temperature contrast, the collision of radically different air masses, the gradient between a cold Arctic air mass pressing south and a warm moisture-saturated Gulf air mass driving north. The steeper that temperature gradient, the more energy available to the storm. The deeper the low pressure becomes, the faster the winds around it rotate. And in March 2026, that temperature gradient is being steepened by two simultaneous factors that have never been combined at this magnitude before. The Arctic air pressing down from Canada is cold in the way that late winter Arctic air masses always are. But the Gulf air it is colliding with is not normal late winter Gulf air. It is anomalously warm, anomalously moist, anomalously deep. The product of a Gulf of Mexico that has been running above historical surface temperature norms for an entire season, feeding moisture into weather systems at a richness and depth that no prior generation of meteorologists has had to factor into their forecasting models at this scale. That collision, historically cold Arctic air meeting, historically warm Gulf air, is what gives this storm its two completely different characters simultaneously. It is why one side of the system is burying Wisconsin under 4.5 feet of snow, while the other side is generating tornado watches for the nation's capital. The same temperature contrast that builds the blizzard builds the severe weather threat. They are not two separate storms that happen to occur at the same time. They are two faces of a single atmosphere expressing the full extremes of its range in a single event. Understanding that physics changes how you interpret every data point that follows. The 52 inches of snow in Michigan's Upper Peninsula is not separate from the tornado watch in Washington, D.C. They are connected. They are both produced by the same catastrophic collision of air masses at the outer edge of what the atmosphere of 2026 can assemble. And that connection is what makes this storm's historic turn different from any individual weather event that preceded it this spring, different from the February blizzard, different from the March 5th outbreak, different from the March 10th outbreak. Those were significant events. This is a compound event, a convergent event, a simultaneous expression of multiple extremes event that the historical record will study not just for what it did in any single category, but for what it revealed about the atmosphere's new to do multiple extraordinary things at once. There are storms. And then there are events that the atmosphere assembles once in a generation. Events that bend the historical record in multiple categories simultaneously. Events that force meteorologists to reach for language they do not use lightly. What is unfolding across the United States right now, from the blizzard-buried Upper Peninsula of Michigan to the severe weather corridor stretching from the Ohio Valley all the way to the East Coast, is that second kind of event. Not a storm, an event. And the turn it has taken in the last 24 hours, the simultaneous escalation on both its winter side and its severe weather side, the convergence of two completely different atmospheric disasters happening at the same time across the same country, is the kind of turn that will be written about in meteorological journals, referenced in congressional testimony about emergency preparedness, and remembered by communities from Wisconsin to Washington, D.C. for decades. This storm just took a historic turn. And right now, before it finishes delivering its verdict, you need to understand exactly what is happening and why it matters to you personally. Start with what is already documented, because the numbers on the winter side of this storm are not forecasts anymore. They are confirmed measurements, and they are extraordinary. Near Round Lake in Michigan's Upper Peninsula, storm total snowfall has reached 52 inches. Not a forecast, a confirmed measurement. Near Shingleton, 48.5 inches. Near Herman in Baraga County, 45 inches. Near Ishpeming, 38.6 inches. At the National Weather Service office in Negaunee Township, 36. 3 inches fell over just 2 days. A new 2-day snowfall record for that location, shattering its previous mark. These are not numbers from the Rocky Mountains or from ski resorts where extreme snow is expected and celebrated. These are numbers from populated communities in the upper Midwest, where roads are buried, power lines are down, buildings have collapsed under snow load, and more than 140,000 customers lost power in Michigan alone. Governor Gretchen Whitmer declared a state of emergency for 7 counties in the Upper Peninsula and northern Lower Peninsula as road blockages, downed power lines, and prolonged outages made large portions of the region functionally inaccessible. This is not a storm that inconveniences. This is a storm that isolates. In Wisconsin, the numbers are equally staggering. Wausau recorded 30, 9 inches total, the city's largest snowstorm on record. Of that total, 23. 4 inches fell in a single day on March 15th, making it Wausau's snowiest single day ever recorded, surpassing a previous record of 15. 7 inches set in February 2019 by nearly 8 inches. Green Bay recorded 26.6 inches, the second largest snowstorm in the city's entire history, behind only an event from 1888. The National Weather Service recorded 14, 8 inches in a single day at Green Bay, the snowiest single day in 137 years. Wisconsin State Patrol reported over 90 crashes from the storm, 11 of which resulted in injuries. Interstate 94 in Jackson County closed after 2 semi-trucks became stranded. Municipalities in the Green Bay area suspended plowing during the worst of the storm because their equipment was getting stuck trying to clear roads where snow was falling at 3 inches per hour. 3 inches per hour. That is the rate at which a forecaster watches a city disappear. The blizzard was officially rated a Category 5 on NOAA's Regional Snowfall Index, a designation it received with a score of 26. 97, making it the first storm to reach Category 5 on that scale since the January 2016 United States blizzard that shut down Washington, D.C. a decade ago. The atmospheric pressure at the storm center dropped to 944 millibars. Explosive cyclogenesis, a bomb cyclone. And bomb cyclone is not a term invented for dramatic effect. It is the correct technical description of a storm whose pressure drops 24 millibars in 24 hours. This one dropped far more. What makes this storm historically unprecedented is not the blizzard alone. Historic blizzards happen. The upper Midwest has buried itself before and dug out again. What makes this event something that meteorologists are already calling one of the craziest weather maps they have seen in years is the simultaneous nature of what is happening on the other side of this same system. While communities in Wisconsin and Michigan are digging out from 4.5 feet of snow, the severe weather side of this storm has been targeting the Ohio Valley, the Mississippi River Valley, and now, in what forecasters are calling the most significant piece of this entire event, the East Coast. And the turn it just took toward the East Coast is the detail that elevates this from a significant severe weather episode to something genuinely historic. The Storm Prediction Center has issued a level 4 out of 5 moderate risk of severe weather for the mid-Atlantic on March 16, 2026. That single sentence requires unpacking because most Americans have no framework for understanding how unusual that designation is for this geographic corridor. Moderate risk designations in the mid-Atlantic happen a handful of times per decade. Some years, they do not happen at all. The cities inside that moderate risk, Washington, D.C., Richmond, Virginia, and Raleigh, North Carolina, are not cities that their residents associate with tornado watches and destructive wind events. They are cities of dense urban population, of millions of people who commute on highways that will be affected by 70 to 80 mile per hour wind gusts, who live in structures that were not designed around tornado survival as a foundational requirement, and who have no embedded cultural memory of how to respond when a tornado watch is issued for their zip code. And a tornado watch has been issued for Washington, D.C. A separate tornado watch covers Virginia and North Carolina, more than 36. 6 million people are under tornado watches spanning the East Coast at this hour. That number is not a typo. 36.6 million people under tornado watches on the East Coast in March. The atmospheric setup driving the East Coast severe weather threat is the same setup that produced the blizzard 1,000 miles to the northwest. And that connection is critical to understanding why this storm is not 2 separate events happening at the same time. It is one coherent, massive, multi-phase atmospheric system expressing different sides of its character across different geographic zones. A powerful extratropical cyclone emerged from the Rocky Mountains late on March 14th and has been strengthening as it tracks northeast. Its northern and western quadrants are producing the historic blizzard. Its southern and eastern quadrants are generating the severe weather environment. A shortwave disturbance embedded within the larger trough is pivoting toward the Cumberland Plateau before rapidly accelerating northeast toward Quebec. As that disturbance accelerates, a trailing cold front is advancing eastward across the Appalachians toward the Atlantic coast. Ahead of that cold front, low-level moisture has been returning northward along the Atlantic seaboard, with surface dew points reaching 60 to 62 degrees Fahrenheit across the mid-Atlantic and 64 to 67 degrees across eastern North Carolina and Virginia. Those dew point values in mid-March are not normal. They are the fuel that transforms a wind event into a tornado event. And they are loaded directly into the path of a cold front moving at highway speeds. A front whose associated storm motions are fast enough to support longer track tornado paths if discrete supercells develop ahead of the main line. The timing of this severe weather threat is a dimension that deserves its own focused attention, because timing is everything when it comes to community response. The reference forecast for the system places the initial supercell development beginning around 2 to 3 p.m. in the St. Louis and Little Rock corridors, with the line of storms rapidly organizing and intensifying by 4 to 5 p.m. and reaching its peak intensity of 60 to 80 mile per hour wind gusts and embedded tornadoes through Memphis, Clarksville, Paducah, and western Kentucky between 8 and 10 p.m. That is a nighttime event, a nocturnal severe weather threat. When the atmosphere produces its most violent weather after dark, when schools have closed, when families have returned home, when the ambient noise of daily life has quieted, when people are beginning to prepare for sleep, the margin for response collapses. A tornado warning issued at 9:15 p.m. reaches people who are in bed, who did not have the weather radio on, who assumed the storm passed because the thunder stopped for a few minutes. The previous severe weather outbreaks in 2026, the March 5th through 7th event, the March 10th through 12th event that produced 105 tornadoes and confirmed a 6. 14-inch hailstone in Kankakee, Illinois. Both had significant nocturnal components. This event does too. For Memphis, Clarksville, and western Kentucky, the peak of the wind and tornado threat arrives when most residents are either asleep or preparing for sleep. That is not a planning assumption. That is a documented fact about where the maximum instability and the arriving squall line's timing intersect on Sunday night. As this squall line marches eastward through the overnight hours, reaching Chicago around 7 p.m. western Michigan, and the heart of Memphis around 8 to 9 p.m., then pushing toward Chattanooga, Huntsville, and Detroit by midnight, Cincinnati by 1 a.m., before moving through Columbus and Cleveland and across the Appalachians. It maintains its intensity through each time zone transition. The strongest embedded tornadoes in a QLCS event like this one typically occur where the line's bow signature is most pronounced, where the surface winds feeding the storm are richest with moisture, and where the nocturnal low-level jet has had time to strengthen. Those conditions tend to align in the most vulnerable part of the storm's track, not the leading edge where warnings come first, but the rear flank segment where the QLCS has organized itself fully and is drawing on hours of accumulated energy. The communities in Tennessee, Alabama, and Kentucky need to understand that being in the second or third wave of the system's passage does not make them safer. In many QLCS events, it makes them more vulnerable. Then Monday arrives. And Monday's story is the East Coast, and Monday's story is where this storm took its historic turn. Because the level 4 moderate risk for the mid-Atlantic on March 16th is being accompanied by explicit language from the Storm Prediction Center that few Americans who live in that corridor have ever seen directed at their communities. Fast-moving thunderstorms that may become widespread during the afternoon and evening. A few supercells potentially capable of producing strong and long-track tornadoes. Widespread damaging wind gusts. The potential for storms to later consolidate into a prefrontal squall line producing destructive winds transported down from upper levels. The environment for Monday along the East Coast is described by meteorologists as one of the most favorable they have seen in 5 or more years for significant damaging winds and tornadoes. Surface dew points in the mid-60s across Virginia and the Carolinas in mid-March are anomalous in a way that cannot be separated from the broader atmospheric pattern that has made 2026 a season of records. The same Gulf moisture that has been anomalously deep and persistent all year, the same moisture that powered the Kankakee EF3 and the Union City, Michigan EF3, and the Beggs, Oklahoma EF3, is now feeding Monday's East Coast severe weather environment. And the population in Monday's risk zone is a population that deserves specific acknowledgement because 36 million people under a tornado watch in the mid-Atlantic is not a number that can be managed by the same institutional frameworks that manage tornado watches in Oklahoma. Washington, D.C. has no tornado culture. Its dense urban architecture, row houses, apartment complexes, office buildings with glass facades, was not designed with tornado survival as a design priority. Its population does not know reflexively what to do when a tornado warning fires on their phone at 3 p.m. while they are in a building with no basement. Richmond, Virginia has the same gap. Raleigh, North Carolina has the same gap. These are not failures of the people who live in these cities. They are structural realities of communities that have never needed to build the tornado survival culture that exists in Oklahoma City or Wichita. But this Monday, those communities are inside a moderate risk. They are inside tornado watches. And the storm line will arrive during peak afternoon hours with highway speed forward motion that will give some communities fewer than 10 minutes between a tornado warning being issued and the storm making contact. What the March 13th through 17th, 2026 storm complex represents, the official name now attached to this event in meteorological records, is something that the historical record will study for the specific reason that it tested multiple American preparedness systems simultaneously. The blizzard system tested upper Midwest communities with Category 5 conditions not seen since 2016. The severe weather system tested Midwest and Ohio Valley communities with a large nocturnal QLCS event during a season that has already produced more than 100 confirmed tornadoes in Illinois alone. And the East Coast system is testing the Mid-Atlantic with a moderate risk designation that arrives in cities where no living resident has meaningful tornado survival experience. Each of those tests alone would be a significant weather event. The fact that all three are being administered simultaneously by the same atmospheric system, expressed simultaneously, demanding simultaneous emergency management responses across the entire central and eastern United States, is what makes this storm historic. The Wisconsin State Climatology Office described March 2026 as a severe case of mid-March weather whiplash, and that phrase captures something real. Less than a week before the blizzard hit, many Wisconsin communities had reached their first 70-degree temperatures of the season. People had put their shovels away. Winter coats were in the back of closets. Snow tires had come off vehicles. The psychological transition away from winter preparedness was underway across the entire upper Midwest when the storm emerged from the Rockies and began strengthening to its Category 5 designation. That whiplash is not a quirk of March 2026. It is a documented characteristic of the ENSO transition pattern driving this spring's atmospheric instability, the same pattern that has created violent, severe weather in states like Illinois and Wisconsin that were not historically primary targets. The atmosphere of 2026 has been delivering weather whiplash since January. March simply delivered it in its most dramatic possible form. 7 days from 70 degrees to 4.5 feet of snow, with a tornado watch in effect 1,000 miles to the southeast. On the same day, the snow was falling at 3 inches per hour. The 500,000 power outages confirmed across the United States from this storm are not just a number. They are 500,000 households navigating the intersection of blizzard conditions and power loss simultaneously. Conditions that create a category of danger that neither hazard produces alone. When power goes out during a blizzard, heating systems fail. Electric vehicles cannot be charged. Medical equipment stops working. Carbon monoxide poisoning becomes a serious risk as people improvise heating solutions. Elderly and disabled residents in isolated communities become completely dependent on emergency services that are themselves struggling to operate in whiteout conditions. Governor Whitmer's emergency declaration for 7 Upper Peninsula counties was not a procedural gesture. It was an acknowledgement that parts of Michigan had become functionally disconnected from the emergency response network that Americans rely on when their lives are at risk. The prior March outbreaks established the cumulative weight this season was already carrying before this storm arrived. The March 5th through 7th outbreak confirmed 32 tornadoes and 8 fatalities, including an EF3 with 160 mile-per-hour winds near Union City, Michigan. The March 10th through 12th outbreak confirmed 105 tornadoes, killed 3 people, and produced a 6. 14-inch hailstone in Kankakee, Illinois, possibly the largest ever documented in the state. And the February 2026 blizzard, which killed 30 people, produced 37. 9 inches at Rhode Island's T.F. Green Airport and knocked out power for more than 600,000 customers, was rated Category 3 on NOAA's Regional Snowfall Index. The current storm is Category 5, 2 full categories higher, the first to reach that threshold since 2016. These are not random extreme weather events clustering by coincidence. They are sequential expressions of the same underlying atmospheric reality, a 2026 spring season running on atmospheric fuel that has no precise historical comparison, producing events that keep exceeding the records that the previous event just set. The storm has taken its historic turn. It was written in Wisconsin snowfall records. It was written in Michigan emergency declarations. It is being written right now in East Coast tornado watches that have never been issued for these cities in this month, and it will be written in the damage assessments, the power restoration timelines, and the emergency management after-action reports that follow. The record books are being updated in real time. The only question left is what you write in your own chapter of this event, whether you use the hours still available before the atmosphere finishes delivering its verdict, or whether you discovered too late what the data was telling you all along. One more dimension of this event demands to be named plainly because it sits at the intersection of meteorology and public accountability.